Let's now look at some examples from sheet 2. Okay, we have the same familiar data and I've already named them. Make sure that you name the data. Now the first example is a hypothesis test about the average MPG. The question is whether the given sample data support the claim that MPG of cars manufactured by the 5 countries exceeds the standard of 22 miles. So now we have to first set up the hypothesis. Generally speaking, it is easier to set up the alternative hypothesis, which is the statement that needs to be proved. Here we want to prove whether the MPG exceeds 22 miles, so that's what should be in the alternative hypothesis. Exceeds 22. Put the number 22 in a separate cell. So then the null hypothesis will be the opposite of this, which will be less than or equal to 22. Now we need to gather some summary statistics so that the t-value can be calculated. So first is we want the sample size, and that is count MPG. We need the average value, so we compute average MPG. Then we need the standard deviation, so that will be stdev dot s for sample. Okay. Now the denominator for the t statistic is the standard error, s over square root of n. So let's find that. That will be s over square root of n. So that is the standard error of x bar. Okay, format these numbers as we go along. So now t can be calculated using this formula, where x bar is here and mu sub 0 is the value of mu in the hypothesis. So mu sub 0 in this case is 22. So we go x bar minus the value of mu in the hypothesis divided by the standard error. That gives us the value of t statistics calculated. Now the degrees of freedom is n minus 1. So that is n here minus 1. Next, is this a one-tailed test or a two-tailed test? Well, you look at the alternative hypothesis. If it is not equal to, then it is a two-tailed test. If it is other than not equal to, then it is a one-tailed test. So one-tailed test. Now, what formula should we use for p-value? Okay, so let's take a look. Okay, so here are the two t distribution functions. So for one-tailed test, we need to use t.dist.rt function. Okay. So t.dist.rt, and we must use the absolute value of the t always, absolute value of t, and then the second parameter is degrees of freedom. Okay, so that gives us a p-value of 0.67%. Now based on that, we can make a conclusion. Since p-value is less than alpha, if it is not given, you assume alpha to be 5%. That's the default value. So p-value is less than 5%, and therefore we reject the null hypothesis. Okay, what does that mean? The interpretation has two parts. One part is about the conclusion, the other part is about the p-value itself. Okay, I have prepared the interpretation, so we'll look at what that means. Okay, So the first part is we have sufficient sample evidence to conclude the average MPG of all automobiles manufactured by the 5 countries is greater than 22 miles, because we've rejected the null hypothesis, so we're going with the alternative. Now, but there is a probability that this conclusion will be false, and that is the p-value. So the probability that this conclusion is wrong, that is type 1 error, is 0.67%.